Hello, my dear children, and welcome back. I can just feel the exam pressure building up, isn't it? But you know what? Fikr not. Don't you worry one bit. Together, we are going to make this chapter, Amines, so easy. Before we start, just do me a small favor and hit that subscribe button. And of course, tell me in the comments what you want to revise next. Chalo, let's dive right in.
So what's our game plan for today? It's a super simple 5-step master plan to just conquer this chapter. First, we'll say hello to the Amine family. Then we'll figure out what's in a name. After that, we have the main event, a competition to see who is the most basic. Then we'll meet a truly magical member of the family, and we'll finish up with those exam reactions that your teachers just love to ask about. See, it's a logical path. Let's begin.
All right, so let's jump right in. First things first, we need to get introduced to the main characters of our story today, which is, of course, the Amine family. So you might be asking, Sir, what even are amines? Well, trust me, it's very simple, beta. Just imagine a family tree, and at the very top of this tree, we have the head of the family, the parent molecule. And that parent is
Ammonia, NH3. You can think of this as the mommy-papa molecule of the entire family. Now look closely. See that pyramidal shape? And more importantly, see that unshared pair of electrons sitting on the nitrogen? That little pair of electrons, beta, is the secret to everything. It's the secret ingredient for almost all its properties. Don't forget that.
Okay, so what happens when our ammonia parent starts having kids? Simple. It just swaps out its hydrogen atoms for some other groups, like alkyl or aero groups. If you replace just one hydrogen, you get a primary amine. That's the first child. Replace 2 hydrogens, you get a secondary amine. And if you go ahead and replace all 3, well, you get a tertiary amine. That's it. Primary, secondary, and tertiary. 1 degree, 2 degree, and 3 degree.
You know how we all have a ghar ka naam, a nickname, and then our proper school ka naam? Well, amines are just like that. They have a common name and an official IUPAC name. And yes, for the exams, we need to know both. But don't you worry, it's actually very easy.
So let's look at an example. For the common name, it's so easy, you just say alkyl amine. So CH3NH2, that's just methylamine. Simple. For the official IUPAC name, the rule is alkanamine. So methane becomes methanamine. Now for the other one, when you have groups attached to the nitrogen, we just put an N in front. So ethylmethylamine becomes N-methylethanamine. That N just tells us, hey, the methyl group is on the nitrogen. Easy peasy.
Okay, everyone, pencils down for a second. I need your full attention here. This next part, this is where the marks are, okay? This is the VIP section of the chapter. We're going to hold a little competition to find out which amine is the strongest base. This is probably the most important concept you need to know.
But before we dive into the competition, let's ask a fundamental question. Why? Why are amines basic in the first place? What gives them this property? Think back to our parent molecule, ammonia. What was its special feature? You got it. It's all because of that lone pair of electrons. Think of it like the nitrogen has a free helping hand that it's just ready to give away to a proton. And in chemistry, any substance that can donate an electron pair is called a Lewis base. So the entire game is about how available this lone pair is. That's the key.
Now have a look at this scoreboard. These are the pKb values. Now listen carefully, my dear children. I'm going to give you a super trick. Just remember this. The smaller the pKb, the stronger the base. That's it. It's just like your rank in an exam, right? A smaller rank means you did better. So looking at this, ethanamine is a stronger base than ammonia, and aniline, well, it's a very weak base.
But why? Well, it's a simple game of push and pull. Think of the alkyl groups in aliphatic amines. They're like good, helpful children. They have a positive inductive effect, or plus I effect, which means they push electrons towards the nitrogen. This makes the lone pair even more available to be donated. But the aryl group in aromatic amines, like Aniline, is a bit naughty. It pulls that lone pair into the benzene ring for resonance. That makes the lone pair much less available.
But just when you think you've figured it all out, there's a twist. In an aqueous solution, the story gets a little more complicated. It's not just one factor. It's a tug-of-war between 3 different things. You have the plus I effect we just talked about, then you have the solvation effect, which is about how well water can stabilize everything. And finally, there's steric hindrance, which is just overcrowding. The final winner depends on a subtle interplay of all 3. It's like a group project where everyone has a different opinion.
So after all that drama, what's the final answer?
For your exam, this is the order you need to just learn by heart for ethylamines in water. The secondary amine is the champion. It's the strongest base. Please learn this order. It pops up in multiple choice questions all the time. Isko ratta maar lo.
Okay, enough of me talking. Let's do a little brain teaser. A very, very common conversion question you'll see. Ready? Get your pens out. How would you convert benzene into aniline? Give it a thought.
So, did you figure it out? It's a really straightforward two-step dance. First, we do the nitration of benzene using our famous nitrating mixture to get nitrobenzene. Then, you simply reduce that nitro group using something like tin and HCl or iron and HCl, and poof, you have aniline. Quick tip, in industries, they prefer using iron scrap and HCl because it's much cheaper.
All right, next up, let's meet a real celebrity of organic chemistry. I'm talking about the magical, the super useful, Diazonium salts. Think of these as the joker card in a deck of cards. You can use them to make so many other compounds. They are incredibly useful.
And this is how we make them. We take aniline, we react it with nitrous acid. But listen to me, the most important thing on this slide, the one thing you absolutely cannot forget, is the temperature. It has to be kept very cold. 273 to 278 Kelvin, which is just 0 to 5 degrees Celsius. If you forget to write this condition in your exam, you will lose marks. This special reaction has a name. It's called diazotation.
Okay, we are in the home stretch now, Bacho. Let's wrap up with two superstar name reactions involving our magical diazonium salts. Trust me, these are the absolute darlings of every examiner. You will almost certainly see one of these on your paper.
First on our list is the legendary Sandmeyer reaction. Can you say it with me? Sandmeyer. Perfect. This reaction is all about kicking out that diazo group, which is a fantastic leaving group, and replacing it with something else.
And look how beautifully simple it is. That diazonium group just wants to escape as nitrogen gas. It's like, I'm out of here. So you just treat it with a cuprous salt, like CuCl and HCl, and boom, the chlorine atom just takes its place. And you can do the exact same thing to add a bromine or even a cyanide group. See? So incredibly useful.
And for a grand finale, we have the coupling reaction. Now the name says it all, right? We're going to couple, or, join two things together. This reaction is actually how we make so many of the beautiful, bright colors you see in dyes for clothes and food. What happens here is the diazonium salt acts as an electrophile. It's looking for electrons, and it attacks another ring that's rich in electrons, like phenol. The two rings get joined, or coupled, by this N-double bond N bridge, and they form a colorful azo compound. The one you see here is a beautiful orange dye. Phew, okay, let's take a deep breath. What did we actually learn today? Let's do a super quick recap. We learned that amines are just the children of parent ammonia. We learned that their basicity is just a game of push and pull effects on that lone pair. And we learned that diazonium salts are like magic keys. Now, I'm leaving you with a little homework question. Why is direct nitration of aniline a bad idea? Think about what aniline is and what nitrating mixture contains. Put your answers in the comments. Don't worry, my children, you are going to do wonderfully. Just keep revising, stay calm, and I'll see you in the next one. All the very best.